O-RAN, the RIC, and SMO.
Excellent. So, hello everyone. Great to be here this morning, especially to follow the presentation of Richard about the RIC, because our topics are very aligned and very related. So, okay, I'm Director of Product Management at Juniper Networks, and I work in the CTO office, and I'm in charge of the portfolio of for O-RAN, so covering the RIC, the SMO, and also the XApps and RApps. And as you'll see also, we have a very strong focus on network slicing for delivering SLAs in this context. So for this session, we'll look at how the RIC and the SMO are contributing to the delivery of the O-RAN promise, a promise that is about openness, it's about interoperability, multi-vendor environment, but also about bringing in innovation into the RAN with the use of applications, which can be AI, ML based. So for this session, what I'll do is I'll go over the experience that we acquired over the years. Actually, I'll focus on a few trials and POCs that we have delivered. And as you'll see, we, as Juniper, we have the RIC and the SMO, but we're not in the business of developing RU, DU, and CU. So that means that our RIC is built from the ground up for being a multi-vendor RIC. So we have to, of course, interpret and work with multiple vendors of applications. Of course, we develop our own as well, but trying different applications of XApps and RApps. And also, we have to work with different vendors of network functions. So really using the RIC as a multi-vendor platform to deliver the O-RAN vision. So with this, let's just start with just a quick overview of what we believe are the key success factors for O-RAN to be successful. So of course, at the beginning, and that's at the very core of everything in O-RAN, that's the O in O-RAN or Open RAN, right? Openness. So openness, it all starts with the specifications, right? Having the industry to contribute and define the standard architecture, standard APIs, tip also to provide, let's say, a commercialization proof point for validation and the badges. And of course, the platform, the interfaces have to be standard and compliant to those. But having the specs in itself alone is not enough, right? We need the whole ecosystem to adhere to these specs, to implement these standards, and to really work as an industry to interpret and have multi-vendor integration. So openness, you'll see that throughout the presentation, is really a strong foundation for everything we do and everything that needs to be done in O-RAN. So next, of course, we strongly believe in the value of automation and control in O-RAN, right? This is being brought into the architecture of O-RAN with the RIC, the RAN Intelligent Controller, and the SMO, the Service Management and Orchestration Platform. So we'll talk at length about these two key components of O-RAN during this talk. And last but not least, the real value of O-RAN comes when we have these two pillars, right? Then we can start talking about bringing innovation, delivering innovative use case in O-RAN, and these use cases indeed can be categorized under different buckets, right? There are CapEx and OpEx savings use cases like the SUNS, energy savings, QE, QoS optimization use case, and of course, there are a bunch of use cases that bring new business model and new monetization opportunities, and of course, network slicing is at the very core of that in the 5G setting. So these are some key foundation that we'll be talking during this presentation. So, and before talking about the actual trial and the experience we'll learn, I'd just like to take a few minutes to review the O-RAN architecture. It's a very simplified architecture here, and highlight the key components that we'll be talking about. So, of course, at the bottom of this, there's of course, the RAN network functions, the RU, the DU, and the CU. And these functions can be either physical network functions, PNF, or cloud native or virtualized as CNF or VNF. In that case, they run in the O-Cloud infrastructure defined by O-RAN. That's really a distributed cloud environment that can be, coming from multiple providers, can contain tens of thousands of cell sites, edge cloud, regional cloud, and so on. So it's highly distributed, disaggregated infrastructure, and also, of course, the network functions as well. Then, on top of that, and that's going to be mostly the topic of discussion, comes the RIC in the center. The RIC, as you know, has two flavors, right? So there's the non-real-time RIC and the near real-time RIC. They both run applications, RApps on the non-real-time RIC and XApps on the near real-time RIC. They have different role and responsibilities into the O-RAN architecture. Also, their control loop is different, right? The near real-time RIC is normally deployed closer to the DUs and CU for having a faster control loop. The near real-time RIC provides control to the network functions, whereas the non-real-time RIC has a much broader scope of visibility to accumulate data from the entire network. And then instead of providing near real-time control, it provides policy guidance to the various near real-time RICs that are deployed in the entire networks. And again, the applications, they can come in pair of RApps and XApp depending on their level of operation and how they are deployed on the RICs. So we'll talk at length about the RIC, and we'll talk also about the SMO, which is represented with the big rectangle over here. So the SMO is composed of multiple functional block. So this is in no means a software architecture, but this is just representing the functional block. So at the very left of this diagram here is what ORAN called the FOCOM. That stands for Federated O-Cloud Orchestration and Management. That's basically the ability to manage the lifecycle of the infrastructure, so the O-Cloud. So let's say, bootstrapping from zero-touch provisioning new O-Clouds or new cell sites, right? Managing lifecycle of these clouds, scaling in, scaling out, managing the faults. So the whole lifecycle of the O-Cloud infrastructure is provided by the FOCOM component. So that's one. The NFO next, that stands for Network Function Orchestrator, that can be similar to the ETSI and FVO, right? Whereas in the ORAN, the NFO is not necessarily restrained to an ETSI environment, so it can run also cloud-native, let's say, infrastructure with Kubernetes. So the NFO is responsible for deploying the workload. So the containerized, virtualized workload, the VDU or the CUs can be deployed through the NFO as the Network Function Orchestrator for ORAN. Then we talked about the RIC, and then last but not least, the RAN NSSMF is defined by 3GPP, but it is also embedded into the ORAN architecture. That is the RAN slice subnet management function. That's really the ability to manage the FCAPs, the provisioning of the slice of the RAN slices, if you like. So basically creating slices, managing their fault, their performance, their configuration, and then once they are up and running, the RIC and the XApps RApp can take control over these slices to ensure that the SLA of the slices are respected at all times. So these are the main components that we'll be talking, and we'll look at some trials and POCs that we have delivered using these components. So starting with the RIC. So I'd like to talk about 4 different use cases that have been trialed recently. There are more than this, but highlighting these 4. So first category, and I'll dive into this, is about admission control. Next one is about traffic steering. Third is energy saving. And last but not least, the RAN slice SLA assurance. So starting with admission control. So this is a use case that runs as an XApps and an RApp that we've trialed and demonstrated at various occasions. And in particular, I'd like to highlight 2 different trials that we've run with this. And in this case, the partners also are public, so I can name the partners that were engaged with us. So the first mention I would like to make is we've run a trial at Vodafone on their commercial network in Turkey. So that was a real field trial with the RIC and the admission control application. In this case, the RAN vendor was Parallel Wireless, and the XApp RApp was developed by Juniper. So that was completed this year, end of 22. And the other mention that I'd like to make, here the operator is not public, so it's a tier 1 operator, but the demonstration was made on it was a lab trial in that case, was made on a 5G network with network slicing enabled. So in that case, we called it slice-aware admission control because the SLA, the admission control requirement, they came from the slice definition. So really we orchestrated the slice with the RAN and SSMF that you saw earlier. We provided the SLA of the slice through the GSMA GST parameter, and then this was propagated to the RIC, and the RIC in real time ensured the admission control, and enforced the admission control policies. In this case, the RAN vendor was Casa Systems. So how it works now. So admission control is really about when a network is under provision, meaning that there's not enough resource to serve all the admission requests by the UEs, by the end users. Right? So in this case, the network has to make decision as to who is admitted on the network and who is rejected. 3GPP defines some mechanism with the 5G core or the EPC to do admission control, but with the RAN and the RIC, it brings additional capabilities where you have visibility into the specific cells, and then you can start doing some intelligent balancing of the admission request across the cell. So if a cell is, let's say, if a slice, as an example, has an SLA of 1,000 admitted UEs on the slice, right? So if all the cells are used at the same level, so there's no problem. You can do a fair sharing of the admission. But what if, let's say, during rush hour, right? So in the downtown, there's a lot of utilization, but in the neighborhood, there's no utilization request. So with the RIC, the admission control XApps and RApps, you can realize the utilization on a per cell basis and then change the admission policies on a per cell to admit more users or less users depending on the cell. And you can do that also across slices, depending on the SLAs, the priority of the slices. So that's one use case that we have trialed again, in this case in 2 settings, but we've demonstrated that many more times, but these were 2 important ones to discuss. So it enables priority access to the network for any user at any time based on policies and configuration. Next one is traffic steering. So traffic steering is a use case that was co-developed with a partner, Parallel Wireless. They have actually developed the XApp. They were providing the network functions, and Juniper, we have developed the RApp to drive the policies for that XApp. So this again was demonstrated, not demonstrated, but trial at Vodafone on their live network in Turkey, in the same trial as the admission control that we saw. So traffic steering here is about optimizing the network utilization of the network resource. So the RIC is looking at all time at the XApps, RApps are looking at utilization of the cells across the network. And if a cell becomes congested at some point, then the application can make decision as to, well, first of all, look at the UEs, the users, which one are suffering from this congestion, are having low throughput effectively, and then decide on whether it's possible to steer these users, attach them to other cells or hand them over to other base stations. So that's the use case of traffic steering. So where you see in this case, this user is attached to that cell, but then it's congested, so the RIC and application will make the decision to offload to this cell here to remove, so it has 2 benefits. It reduces congestion of the cell, and it also improves the user experience because it gets additional throughput. And that's what we've seen in this trial in the commercial network. So on average, for cells that were congested, when doing traffic steering like this, it was possible to get to 15–30% average throughput increase across the cell. And for those users that were severely impacted by congestion, that were steered to other cells, then we reached up to 40% of throughput improvement. So next is a very important topic about energy savings, right? So that's another use case that runs on the RIC that we have demonstrated in different opportunities. So one of those was in a ORAN Plugfest. So in this case, it was running the energy savings applications from Juniper, and we were partnering with Keysites for the simulation of the platform, the RUs, the Us, and CUs. So that was realized in a Plugfest at ORAN. Another opportunity where we demonstrated this is at MWC. We announced a collaboration with Era Technologies, a startup in AI that develops AI ML-based application. And in this case, Era has developed an RApp. It was only the RApp in this case, not the XApp, but the RApp was controlling through the O1 mechanism the energy savings of the RAN network. In this case, it was simulated with the network function simulators of VIAV. So again, we integrated with another vendor of network function or simulator in that case. And in these simulation, we observed up to 20% of energy savings with this use case. And then last one I want to mention here is about RAN slice SLA assurance. So as we discussed at length in this session, right, ensuring the SLA is a great way, it's a great new opportunity in 5G to deliver services that are tailored for the needs of the users, and how to ensure the SLA is respected at all time, and so on. So through the RAN slicing management function, we can provision the slices. The slices can be created. So the day 0, the day 1, provisioning and operation of the slice, the FCAPS. But now when it comes time to optimize the slice to make sure they respect their SLA at all times. So what if the throughput requirements are not met, the the latency requirements are not met, then the RAN slice SLA assurance can come into play to make decision either prioritization or changing configuration or control over the A1, E2 channel of the RIC. So this is another use case that we have demonstrated in PlugFest, again with Keysight. The application in this case is coming from Juniper, and Juniper is investing a lot in slicing, either slicing management and slicing SLA assurance. We have a lot of patents in this area and also a lot of contribution. We're driving, for example, at ORAN in the working group 1, the slicing activities, and we're deeply engaged into many working groups related to slicing from 1, 2, 3, 6, and 9 as well. So, okay, assuring the SLA of the slice. So these are 4 use cases that I wanted to highlight here. Of course, the goal and the ambition is to create, just like an app store for mobile phones, right? You want to welcome as many vendors of applications to develop on our RIC and have the broadest possible portfolio. And for this, we are offering to the vendors an SDK to develop application and open APIs. So ORAN is defining the APIs, the RIC API on the near real-time RIC and the R1 API on the non-real-time RIC for applications to develop on the RIC. So we're definitely contributing to these specifications. The specification at ORAN are not completed yet, so they're in stage 1. So the general principles have been defined, but the stage 3 specifications are not completed. So the way we approach that is, of course, we're contributing at ORAN, we're deeply engaged into the specifications, but we're not waiting for ORAN in the sense that we have implemented pre-spec R1 and RIC APIs, and of course, contributing into the spec, and then we will be complying with the spec as they evolve if they deviate from what we believe they will be achieving. So the key learnings from this, right? So first of all these trials and these POCs, they are confirming that the RIC is an open and interoperable platform. So this is something that we do, that we work on the daily basis. It's extremely important to comply and to follow the specifications, participate in PlugFest in order to make sure there's compliance and interoperability. We have seen over time, so we've been developing the RIC for actually many years. Even before, even before ORAN was formed in the XRAN days, there was some controller that was developed, and then this has evolved over time. So we've seen that there is, with SDKs, APIs, the development times for third-party developers has really accelerated. So there's still improvement to be made there to even further improve the APIs, the SDKs. But we've seen that in some cases, for simple application, the whole porting of the application can take just a few days. Of course, more complex application will take longer, but still it has really accelerated. So that's one of the things we've seen over the year with the RIC. Another thing also is the integration with the CU and DU vendors. Of course, if these vendors are ORAN compliant, supporting the E2 interface, then it's a matter of running the interoperability testing, and it works quite well. Now, if the vendor are not ORAN compliant, so we've also run a trial at a tier 1 operator where we had to integrate with a non-3GPP ORAN compliant vendor. And for this, of course, for the near real-time RIC, if there's no E2, there's no E2. But for the non-real-time RIC, to the FCAPS configuration channel, the O1 or 3GPP mechanism, then it's possible to configure and, let's say, get performance metrics and operate on that. So a lot of learnings there as well. On the real-time management of the radio resources, that's a very important topic. Of course, there's a lot of improvement to be made there. Of course, the RAN vendor supporting the E2 service model is key to enable all the benefits of ORAN. But what we've seen is that it is possible when the vendors, they open up the E2SMs to do that. We've done that with the admission control and with the traffic steering, well, also CSON's applications and so on. And last but not least, we definitely see that the ecosystem is maturing. It's not, we're not fully there yet, but really the ORAN, we see a lot of contribution at ORAN. We see many companies contributing. The specs are maturing, are evolving. The whole operator, the operator industry, from what we see from our vendor point of view, is really a huge interest from operator. So a lot of requests, excellent questions from the operator, willingness in trialing and trying the RIC. So really, it's not like us vendors that are trying to convince operator that this is important. That's the other way around, right? So the ORAN is at the foundation from operator. So the RIC, I mean, your presentation was very clear, right? That the RIC is a key cornerstone of that. And then innovative partnerships are being formed. And of course, there's more and more applications that are being available. Okay, so now let's talk quickly about the SMO. So the SMO, again, is the whole management of the RAN network. The whole telco infrastructure is evolving. We all know that, right? There are different challenges, and it's complex to manage this environment. But let's say let's review these key concepts, like the foundations for the SMO. So of course, the telco infrastructure is evolving, right? With cloudification, with the disaggregation, software-defined everything, right? So this is a whole new concept if we compare to years ago. So these new technologies have to be taken into account when we do service orchestration and management of the telco network. Of course, networks are extremely massive, complex, and this is not getting any easier with the densification in 5G. So SMO have to operate at massive scale. So there's no way this can be done, let's say, manually. It has to become intelligent. And then last but not least, again, is the need for on-demand services on these telco networks. So how do we monetize this investment? How do we also offer differentiated service to the customers to fit their needs, right? Whether this is private mobile networks that can be created with slices on top of the public network, or can be for deploying an MVNO on top of the network, or any industrial or vertical use cases, as we can see on this slide here. So each of them have their different requirements, their different SLAs. So being able to orchestrate and manage these services on top of a extremely massive and complex environment, and with the new technologies that we see as all the challenges that the SMO have to address. So again, just to, there's a display problem here, but just to summarize, the SMO is containing these functions here. So the FOCOM, the NFO, the non-real-time RIC, and the RAN and SSMF, and it collaborates, of course, with the near real-time RIC for the control of the network functions. And one trial that I'd like to mention here is we were asked by a tier 1 operator to demonstrate and prove out that it is possible to realize 5G network slicing in a multi-vendor environment. So really that was the key requirement of that trial, was to go into multi-vendor. So Juniper, of course, was providing the RAN SMO and the RIC in that case. The network functions were provided by another vendor. Core domain management was also another vendor, and at the top level, the service orchestration was provided by another vendor. So it was truly multi-vendor in that case. So in this trial, of course, we learned a lot, right? It's possible with the 3GPP specs, the ORAN specs, to realize slicing. What we've done here is to do the day 0 and the day 1 operation of the slice, so the provisioning, and being able to create 2 slices with sharing of component and SLA enforcement with the admission control and the SLA XAPS and RF. So integration at the beginning, of course, not everybody was adhering to the 3GPP specifications and ORAN specification, but in the end, we addressed the concern, and we were able to succeed in this POC. So that's it. So the basically conclusion, really the takeaway of that presentation is that we need to continue shaping and contributing to ORAN, 3GPP, and the various standard organizations. This is really important. Embracing the open and standard architecture and APIs, and making the radio data available for the industry to evolve and have the application developer to be able to come up with very innovative applications.
Fantastic. Thank you very much. Put your hands together for Marc-Andre.
Thank you.
That's brilliant. Yeah, just one quick question maybe before we go to break. Well, if there's any more.
Okay, thank you.
2 quick questions.
Okay.
Very quick questions. First, in the near-time and the non-real-time RIC, what language do you use to develop the algorithms inside the different
To develop
What language do you use? Like Python or R or whatever the languages normally Juniper use?
Okay.
Yeah.
So our RIC is, first of all, is built on the ground up, from the ground up with cloud native principles. So it runs as Kubernetes applications. So it's a mix of Go language implementation and C++. So that's the RIC. And the application then can be completely independent. We have open APIs and SDK. So application can be completely different, but these are languages.
So you still leverage the open API interfaces.
Of course.
Let's say it doesn't matter if I use Python or R or MATLAB for the algorithm application part, right?
Yes. No, application, that's fine. Yeah, the open API is well defined. Also, we have SDK. SDK, we have some Hello World application to show you how to use it, operate it, and yes, exactly.
Okay, that makes sense. Can you please go to the SMO slide? Over here. So you address the NSSMF for the RAN and also for the 5GC NSSMF. Actually, in their northbound, there are two different network entities like NSMF and the CSMF. Are you going to place it as a part of SMO in the future, or you take it out of the scope of the SMO? Over here. In our experience, we developed these two network entities for China Mobile and China Unicom, but these two network entities are now part of the 5G OSS system. I'm just asking if you have some roadmap, where are you going to place these two network entities in the future for SMO?
So we can, I can give high-level response to this, and we can definitely talk about roadmap in details separately. But really, so definitely here what I'm showing is O-RAN SMO. So it's in this trial we were asked to provide this part, the RAN part. But you're absolutely right? 3GPP defines CSMF for the communication service management function, the NSMF for network slice management function for end-to-end slicing management, and then in each of the domains, the RAN, the core. Transport is ITF, but the RAN and core, there's the NSSMF for slice subnet. So indeed, the vision is to realize end-to-end slicing. That's really important. So for this trial, we provided the RAN SMO, but in our view, there's a notion of multi-domain SMO that contains indeed CSMF and SMF that has the core NSSMF and the TN. Call it NSSMF if you want. It's IETF, it's a bit different, but the interfaces are being defined. And what is important, though, is that these components, they all use standard APIs. So we see really 3GPP, TM, 4RAM, There's various IETF APIs that are being defined. So adhering to these APIs is really important, and that's what we demonstrated in this POC, so that you can mix and match the components. But yeah, that's a great question.
Fantastic. Thank you very much. I think that's all we've got time for. It's now the coffee and networking break. After we'll be joined by Simona from Bell to dive more into automation as well. But thank you to Marc-Andre.
Thank you.